Yes. So we get started with the next chapter, that is integrals. Okay. So basically, integration is a process. Okay. So if you see what is integration, okay, it is a process of, I'll call it as integrating only. So what is integrating basically? Adding things, right? Yeah. Others technical, basic first time. So it is basically adding. So integration, another you integrate things means you're adding things together. Okay. Now when I say adding, right, you use something like this, right? What is this called as? You call this as sigma. And where do we use this sigma? I told this many times. So if you're saying integration is also a process where you keep adding stuff, then why don't we use a sigma? Why do we need to have some other symbol for it?
Integration is used to find area, sum of
Area of?
area under curve.
Okay. It is an elongated S, basically. Why do we need another symbol? It's not sigma anyway. You can all put limits here also. No? I is equal to 1 to n. I is equal to 1 to n, I write xi. Why do we need this? Let's see how many of you are able to think. This for? Because very good. This is for discrete data. Where do you use sigma? Mostly in statistics. So in statistics, what are the kind of data you have in your hand? All are discrete only, you know. Suppose where do you mostly use that? Why is statistics even used for this particular? No other job or summa of the cumulative frequency, that frequency. Why do you study all this? So you have some, if I give you some data, I ask you to analyze and give it to me. You're going to do that, right? So what do I mean by analyzing? Suppose I might be interested to know how many students secured above 90. Right? How many have secured between 75 to 90? 2 days back results came. No? I wanted to do that. If I need that, I obviously need to know statistics, which Excel will take care. That's a different story, but I need to understand the basics of it. No? What is the average? What is the frequency? All those things. There, the data is discrete. Means the same student cannot score 90 and 95 in the same subject at the same time. It's fixed. You score a 90, it's done. Right? Whereas if there is a scenario where I need to find the same average, but now I don't have the data to be discrete, rather continuous in my hand, like how a function behaves. At the time, what am I supposed to do? I can no more go with the concept of sigma. Rather, I need to go with the concept of integration. That is why if you see integrals are always done for functions. Statistics is always done for discrete data. The discrete data you will club and put it, that is cumulative frequency. The frequency even between 90 to 95, how many people have come, that is a different way of data analysis. But the data will not be continuous. If you want, you can check it 100 times and see. It will not be continuous. But there is a concept where probability and statistics are integrated. On the time, you use only integration because there the data will be continuous. That comes for the genetic behavior and all if you want to analyze, right? Those are all continuous things. There we need to use them. So, sigma is used for discrete value and summation is first thing used for continuous value. So that is why we always have the concept of integrals being used only for functions. Breathe. Is it clear? Right. Now, if you see the name of the chapter, it is not integration, it is integrals. Differentiation, particular continuity and differentiability. Last year, limits and derivatives. You never learned it as differentiation. Differentiation is process. What is derivative? Derivative is the output that you get by doing an operation. For example, the derivative of sin x with respect to x is called as cos x. Here, which one is called derivative? Cos x is called as a derivative of the function sin x. So there also use functions only. So wherever function comes, it is always important that you have the differential coefficient in your hand. That is dx, dy, d theta, whatever you use, you definitely need differential coefficients. Like how you have derivatives, you have something called as integrals also. Integrals is another one. The output that you get on doing the operation called as integration. Okay, that is the name of this chapter. So we are concerned about what are the output values that we are going to get on integrating. Is the point clear? Right? So this falls under a branch of mathematics called as calculus, obviously, and to be more specific, you call it as integral calculus because you have differential calculus and integral calculus. Right? Now, I have to understand how is integration related to differentiation. Like how we told, integration is basically the reverse process of differentiation. What does that mean? What does that even mean? Means if I have a function in my hand, if I differentiate that function, I'll get an output. What is that output? Is it a number or a function? It is also a function. Okay, I'll come to that slowly. When will you get number? When will you get a function? Okay. So when you differentiate a function, the output is also a function. Now, if I integrate the output function, what am I supposed to get? The function which you differentiate. So that is why you call it as reverse process. Means on differentiating a function f of x, let's say you are getting capital F of x on, okay, I'll write it as capital F of x. So on differentiating capital F of x, let's say you're getting small f of x, then on integrating small f of x, you should get back the capital F of x. That is why if you see like how we have something called as first principle of derivative. You remember derivative of sin x is cos x, but if I put a question of how, what will you say? You'll use something like this, limit h tends to 0. Do you remember this? F of x plus h minus f of. So what you call this as? This is technically called as the first principle of derivative. Use this to find the derivative of a given function. But there is no formula for finding the derivative of integral of a given function. You just do the reverse operation out of it. So based on that knowledge, what we can say is, observe. I need to tell you some important point. Make a note of this. So integrals, when you talk about them, they are basically classified into two types. What are they? You call them as indefinite and you call the other part as definite. Indefinite, none other. So indefinite, what is definite? Definite means fixed, right? So indefinite means they do not have any boundaries. So no boundaries are associated. Whereas when you talk about definite, you have boundaries associated. Am I right? So here you have no boundaries that are associated, and here you have boundaries that are associated. Means those boundaries are represented by parameters called as limits. So you have something called as a lower limit and upper limit, right? So what is the symbol for integration? So what is the symbol used? It's like an elongated S. Means if you take Sn, pull it vertically, then it becomes an elongated S that you read it as integral. Integral of something. Frida, right? Now the topic that we need to see is integration as reverse process of differentiation, right? For that, let's take a simple example like this. Derivative of, if I have x square, what is the answer for it?
Sir, with respect to what?
So one guy asked me only, Nitish asked me, with respect to what? So with respect to dx is 2x. With respect to d theta, it will be a 0. Are you able to understand? So d by dx, derivative of x square with respect to x is 2x, which implies, can I write d of x square is equal to 2x times dx? Can I do this? If I treat them like a ratio, a fraction, I'll take the dx to the other side. Now I will do the reverse operation, which is called as antiderivative or integration. So what do I call this as? Antiderivative or integration on both sides. If I do this, then I'll put an elongated s of x square is equal to 2x dx with an integral symbol on the other side. Now observe, this integral and derivative are counter operations of each other so that they get cancelled. You should not cancel them literally like this. I'm just trying to tell you. Okay. So they are counter operations so that you're left out with x square on the left hand side. So what does this tell you? When you differentiate x square, you got 2x, but on integrating 2x, you got back x square. So that is why we call it as a reverse operation. But here, there is a small point that is to be noted. That is, if I take the derivative of x square plus 1, for example, then what would the answer be? It is the same 2x. So derivative of x square plus 1 is 2x dx. Can I write it like this? Yes, I can. If I take the integral on both the sides, what do I get? X square plus 1 is equal to integral of 2x dx. This is where the challenge starts. When you differentiate one function, you have only one derivative. But on integrating the same function, I am getting two different answers. So the problem is it going to stop with 2 or is it going to go for infinite length? It goes for infinite length. So what does this teach us? It tells us the fact that whenever you do an integration without limits, to the function that you obtain, you should always add a constant. Okay? That is why if you see, if I have to generalize this, capital F of x, if capital F of x is the first step, if I have d by dx of capital F of x, which is giving me small f of x, is that clear, guys? Okay. Then derivative of capital F of x will give me small f of x times dx, right? When I integrate on both the sides, it becomes capital F of x is equal to integral of f of x dx. But what is it I'm supposed to add? I need to add a constant. This is what we need to make a note of in the case of indefinite integrals.
Sir, what exactly is the use of this constant?
What exactly is the use of?
The constant that we're adding on the left-hand side.
Sorry? For adding a constant.
So why are we writing it as fx plus c?
Why are we adding a constant? Is that what your doubt is?
Yes.
Okay. So I'm saying integral of x square, sorry. Derivative of x square is 2x. Derivative of x square plus 1 is 2x. Derivative of x square plus 2 is 2x. Is it clear? So from this, integral of 2x dx should give me x square because that is what I differentiated. From this, integral of 2x dx should give me x square plus 1 because that is what I differentiated. Here, integral of 2x dx is giving me x square plus 2 because that is what I differentiate. Like this, if I keep on doing, I add any number here, the derivative is still going to be the same. But the integral of that function is not generating the same function. Once it is generating x square, once x square plus 1, 1 x square plus 2, and it keeps on going like this. So what do you understand from this? So x square plus any constant, if you differentiate, it is still going to be 2x. Where you integrate, you are going to get back x square plus c. Is that clear?
Yes, sir, understood. Yes.
So this is what you're supposed to do when you do indefinite integrals. Is that clear, guys? Now you know the remaining story. You're just going to tell me the formula. Seriya? See, first exercise, they would have solved the problem based on differentiation. But we are not going to go in that way. Before that, I'll teach you how to get the formula for all the functions. Okay. So first, write down the function. Okay, function, let us say derivative, then we'll talk about integral. Okay. If I have the function x power n plus 1 by n plus 1 plus c, okay, I have something like this. When I ask you to differentiate this, what will be the value? So the derivative of this will be x power n. So what can you understand? If I integrate x power n, I'm supposed to get back this function. So what will the question become? Integral of x power n dx is nothing but x power n. So I'm actually going in the reverse. One by n plus 1 into derivative of x power n plus 1 is n power 1 into x power n. N plus 1 and n plus 1 will get cancelled. Clear? Okay. Similarly, if I have sin x, what is the derivative of sin x? Cos x. So what will be the integral of cos x? Plus c. Right? So is this method okay, or you want me to go in the straight direction? Which is this? Are you able to understand? Is okay, va? Confused all? Yeah. So similarly, if it is cos x minus sin x, so if I integrate sin x, what do I get? I'll get minus cos x plus c. Means you should always, if at all you forget the integral, no, you should always see on differentiating which function will I get the question. On differentiating which function will I get sin? Obviously on differentiating minus cos. Okay. Similarly, I have secant square x. Sorry. I have tan x. So what is integral of tan x? Sorry, derivative of tan x. Secant square x. So what will be the integral of secant square x? It will be, that's it. Is that clear? So what I'm trying to say is, tell me the derivative of all the trigonometric functions. Sine, cos, tan, then what do you have? Cosecant x. So we'll go in the order. Reciprocal of sine is cosecant. Minus or plus or? Sure. Okay. Minus cosecant x. Yeah. Correct. But all you forget, what will you do? Write 1 by sin x, apply u by v and derive it. Okay. So minus upper integral of cosecant x cot x will be minus cosecant x plus c. Okay. You have secant x. So derivative of secant x is secant x tan x. So integral of secant x tan x will be secant x plus c. Next, derivative of cot x is minus cosecant square x. So integral of cosecant square x dx will be why are we not differentiating? The integral thing here. Why am I not putting minus cosecant? Because see, I want the question to be positive. That's it. I'm just trying to find the integral of all positive values. Generally, in any no question, you'll write the function to be negative. Right? Same is the case on left hand side also. See, for the function is there. No, I didn't. I could have written what is the derivative of minus cos x. I would have told plus sin x. I didn't start the question like this. I started with cos x only. Prida. Right? 1 minute. So what is the derivative of e power x? So e power x, write it down. Derivative of e power x is e power x. So integral of e power x will be e power x plus c. It is the same function. Those who are online, I hope you are able to understand.
Yes, sir.
So e power x, integral of e power x is equal to e power x plus c. So if I have a power x, it will be a power x log a. So the integral of a power x dx will be a power x pi log a. Okay. So till here, the formula is sufficient for us to solve the first two exercises. So derivative of log x is 1 by x. So integral of 1 by x will be log x plus c. Shall we proceed with some problems? Okay. But I just want to explain this thing. Listen. So there are certain symbols, terms, and phrases that we need to understand. So if you're able to see the first one, you call it as integral of f of x with respect to x. Right? You write it as integral of f of x into dx, but how do you read it? Integral of f of x with respect to x. Second is the f of x in the integral part is called as integrand. That function is called as integrand. The x is called as the variable that we are using for integration. And integrate, right? When I say integrate, I'm asking you to find the integral, means the output. Find the output. Okay. An integral of, what do I mean by an integral of? An integral of means the function that I am able to obtain. So a function f is set such that f dash of x is equal to small f of x. Then integration is a process or operation, whatever you call it. Okay. Then constant of integration is nothing but any real number that you add after finding the integral. Right? All these terms I have already explained. Is the textbook clear? Right. There is something called by parts. That's a separate exercise. You don't apply chain rule actually. You're asking about the product rule. Generally, you don't have chain rule here. You will mostly go with substitution. You do it. You solve it using substitution. So there is only one substitute for product rule, that is called by parts. You don't have chain rule or something. Initially, you will have that confusion between differences. Error? So the formula set is given here. Edra, any doubt? Other than the by parts. Other product rule and so on. He asked me about chain rule. Okay. Okay. So I need to give you some more formulae. Listen. So maybe you can make a note of this. So from here, no, write it in this format itself. Write down derivatives and write down integrals. Make it 2 columns. Don't continue under the format that I gave you. Okay. So write down derivatives and write down integrals. So you know what is the derivative of sine inverse x? What is the derivative of sine inverse x? 1 by root of 1 minus x square. Then what will be the integral of 1 by root of 1 minus x square? Sine inverse x plus c. Okay. So write it down slowly so that it gets registered. Don't be in a hurry. So derivative of sine inverse x is 1 by root of 1 minus x square. Integral of 1 by root of 1 minus x square is sine inverse x. Similarly, what is the derivative of minus cos inverse x? Same. So he is asking one valid question. If you see, integral of 1 by root of 1 minus x square is coming out as sine inverse x plus c or minus cos inverse x plus c. Can you tell me what is the deleted portion of your inverse trigonometric function? Do people properties illa thukitangala? So this is equal to sine inverse x plus c. Third property enna solra, sine inverse x is pi by 2 minus cos inverse x plus c. So pi by 2 plus c, can I call it as some other constant? So integral of 1 by root of 1 minus x square can either be sine inverse x or minus cos inverse x. So when you deal with trigonometry, I wanted to tell this when we were solving problems. In indefinite integrals, there is one problem that will occur. Whenever you're dealing with trigonometry and inverse trigonometry, you will get multiple answers. But all those multiple answers will be right only. Because it depends on how you write the answer. If you get the answer as sin x, you can leave it as sin x. Someone might be interested to write it as cos of pi by 2 minus x. How is it? Right. So it changes like that. Puriyadana? Is this point getting registered? Integral of 1 by root of 1 minus x square is sin inverse x or minus cos inverse x, both are right. What is the derivative of tan inverse x? Derivative of tan inverse x is 1 by 1 plus x square. So integral of 1 by 1 plus x square will be obviously tan inverse x plus c. Or it is also equal to minus cot inverse x plus c. Both are right. Okay. Here. Shall I move to the next one? Okay. So derivative of secant inverse x, 1 by x into root of x square minus 1. So this we would have not used many times. So remember it. 1 by x into root of x square minus 1. So integral of 1 by x into root of x square minus 1 is secant inverse x plus c. Or it can also be minus cosecant inverse x plus c. The other formula I've already given. Okay. But they're saying it should be a positive value. Instead of giving you the domain, they're indirectly telling them. Okay. So there's one more topic which you need to know. After all, it comes in source-based question. So it's better to know. Geometrical interpretation of indefinite integral. So what is the meaning of geometrical interpretation? Wherever you see that word, no, it is not Euclidean geometry, it is coordinate geometry. So what is a geometrical representation basically means is, when you plot a function on a graph, how does it look? Is what the question is. Suppose I have x square. Derivative of x square and on the 2x, no. But how does x square look like on a graph sheet? It is an upward parabola. Suppose I have x square plus 1. Derivative of x square plus 1 is 2x. So this is how x square plus 1 will look like. Means for x square, shift one value in the upward direction along y-axis. Then what about x square plus 2? It is also an upward parabola, but 2 units shifted from the origin. Is that point clear? Right. So it keeps moving in such a way that the derivative of everything is going to be the same. Why I'm saying derivative of everything is same as, if I, so observe, no, see if you're able to understand this. So if I drop a perpendicular, let's say this point is 1, 0. So this point will be 1, 1. This point will be 1, 2. 1, 2 or 4 order. 1, 5. X square plus 1, no. 1, 1. This point will be 1, 3. Because it is x square plus 2. But what is common? X coordinate is common. Means if I draw a tangent to this curve at this point, or this point, what will happen to them? They will be parallel to each other. So that is why the meaning of derivative being the same is applicable. Because what does derivative mean according to tangents and normal? It is a tangent drawn to the curve at the given point. Are you able to understand what I'm trying to say? That is why derivative of x square is 2x, derivative of x square plus 1 is 2x, and the derivative of x square plus 2 is also 2x, and so on. Now, if you do the reverse process, what I'm trying to say is the integral will also be so the integral will be different. Yeah, integral is different. Because the basic meaning of integral, you learn it in applications of integral. Why I'm saying integral will be different is, this area is not the same as this area. Means the area keeps changing. So why do we integrate? So why do we differentiate? To find the slope of tangent. Why do we integrate? To find the area made by the curve with the x-axis. So this is how it works. So that is the meaning of geometrical interpretation. So that's the curve they have given. So they all look parallel to each other, so that the tangents drawn to the curve at x is equal to a is a constant. Means they all have the same value. Okay. So some properties of indefinite integral. Please write it down. First, the process of differentiation and integration are inverses of each other. The process of differentiation and integration are inverses of each other in the sense of the following results. How do the results look like? Here, observe. I have integral of f of x dx. Okay. I want this answer to be f of x. I repeat it. Integral of f of x dx. I want the answer to be small f of x, not capital F of x. It's not some other function. So what should I do? I should differentiate on both the sides. So d by dx of integral of f of x is f of x, because they are the counter operations of each other. Am I clear? So, if there are two indefinite integrals, see, this is applicable only for indefinite again. So, two indefinite integrals with the same derivative lead to the same family of curve and they are equivalent. Write it down. Two indefinite integrals with the same derivative, lead to the same family of curves and they are equivalent. Two indefinite integrals with the same derivative lead to the same family of curves and they are equivalent. Okay. So the meaning of it is integral if so if I have something like this term, d by dx of integral of f of x is equal. So if they say integral of f of x is equal to integral of g of x dx, then f of x and g of x belong to the same family of curves. That is what they say. Okay. Next is, so this is obvious. If I have sum of two functions f of x and g of x, and the integral of it is going to be integral of f of x plus integral of g of x. Okay, this is obvious. Similarly, for any real number, if I have integral of k times f of x dx, then that will be equal to k into integral of f of x dx. Am I clear? Right. Now see, we'll do some problems. Observe. Write an antiderivative for each of the following functions using the method of inspection. So when they use the word method of inspection, if at all in your CBSE exam they ask this kind of a question, you're not supposed to directly go with writing the integral. You should not do that. You should use the logic of differentiation and then come to the point. So for example, if you want to find the integral of cos 2x, okay, if I'm interested to find what is it, now you need to start thinking derivative of which function would give you cos 2x. First of all, derivative of which function will give you cos sine. So we will say we know that d by dx of sine 2x is how much? Is it only cos 2x? It is 2 cos 2x. Okay. Now what I can do is d by dx of sine 2x, half of d by dx of sine 2x is equal to how much? Cos 2x. So d by dx of, I can push the half inside. You are doing exactly the reverse. Had that half been given in the question, you would have taken the half out. But this half is pushed inside. So half of sine 2x is equal to cos 2x. So what you are trying to say is integral of cos 2x is half of sine 2x. So there is a direct method to solve this in one step also. But here, why did I do this? Because they use the word method of inspection. If they do use the word method of inspection, then you need to go with the concept of differentiation. Shall I proceed? Okay. Now the next question is find the antiderivative of 3x square plus 4x cube, again using the method of inspection. Now tell me, derivative of x cube, on differentiating which function will you get x cube? Derivative of which function is x cube? So power should be highest. Higher than that, you will get a lower x power 4. On differentiating x power 4, you get 4x cube. Differentiation will always reduce the power. Integration will always increase the power. Seriya? Is it confusing? Okay. Now listen. Integral of 3x square plus 4x cube dx is equal. So we know that d by dx of derivative of which function is 3x square? Obviously x cube. Derivative of which function is 4x cube? X power 4. So this is the answer. So when you're writing the antiderivative here, you're not adding plus c. Observe. Why are you not adding? Because the question they told, write an antiderivative. Means you write whichever you're okay with it. They're only concerned about function, not the constant. Whereas from next exercise, you'll directly start using the formula. Only you need to add the constant. Be careful. So last one is 1 by x. Derivative of which function is 1 by x? So log x is going to be the integral. So here, if they don't use the word method of inspection, go with the direct integration. Now you know how to solve this. Integral of x cube minus 1 divided by x square. It is integral of x minus 1 by x square dx. Integral of x square by 2 minus integral of 1 by x square. It is minus 1 by x, because on differentiating 1 by x you get minus 1 by x square. So what is the answer? X square by 2 plus 1 by x plus c. This will be the answer. End the step. X cube by x square minus 1 by x square. So x cube by x square na x. 1 by x square na. Okay. So the integral of x is how much? X square by 2. Yeah, na? Integral of x power n dx is x power n plus 1 by n plus 1. So integral of x square dx will be x power, sorry, integral of x dx will be so this is what happens. So another here it is x square by 2. For 1 by x square, I can write it as x power minus 2. So integral of x power minus 2 is x power minus 2 plus 1 by minus 2 plus 1. So what will the answer be? Minus 1 by x square. Yeah. So proceed with the next one. Integral of x power 2 by 3 plus 1. Those who have textbook need not wait for me. Keep doing it. Do it fast.
Second one. How did that plus x comes back?
So integral of x power 2 by 3 is integral of x power 2 by 3 is x power 2 by 3 plus 1 divided by 2 by 3 plus 1 plus integral of dx is x, right? So x power 5 by 3 divided by 5 by 3 plus x plus c. So 3 by 5 into x power and integral of dx எவ்வளோடா? It is x. Is there anyone having doubt? Similarly, integral of, guys want me to do or you are able to do? You're able to do? There is any doubt, I'm expecting you to ask.
It's a log x. The example term in the log x is modulus.
If you want, you can put or else it's fine. But only thing you need to remember is what kind of, yeah, tell me, ma.
Sir, for the third one, they have given it like log of modulus of x. Why is it anything?
No, that's what I told you, no? Instead of giving you the domain, here see, I'm showing this to you. See. I've circled something, see.
Yes.
So that's why they wrote. But not necessary, you need to write modulus every time.
Sir,
Tell me.
sir, integration of constant is x, sir.
Instead of integration of constant is x.
Sir,
Yeah, tell me.
sir, differentiation of constant is 0, sir.
If you ask me differentiation or integration.
Yes, sir. I'm doing the reverse process, sir.
Integral of 2 dx is equal to 2 into integral of dx. The 2 is a constant. Then.
Yes, sir.
Okay, 2 into integral of dx is x.
Okay.
So now whatever is a constant, that constant will get multiplied with x.
Okay, sir.
Yeah. Is there any problem you want me to explain? See, if there is a scenario looking at solution, better ask me. Third one, 1 minus sin x by cos square x. One upon. Okay, I'll tell you. So what he's saying is 1 minus sin x divided by cos square x. I can write it as 1 minus sin square x, and I'll write it as 1 minus sin x into 1 plus sin x. I want everybody to listen. So this and this will get cancelled. You will be left out with dx divided by 1 plus sin x. So if I just look at the function 1 by 1 plus sin x, it is easy to differentiate. But the first thumb rule you need to have in your mind with respect to integration is, please make a note of it. In every problem of integration, the first step is eliminating the denominator. You should not have denominator at all. Okay, please make a note of that. In integration, it is always important to eliminate the denominator. Because for 1 by 1 plus sin x, you cannot integrate it that easily. You can do it, but it will take 10 to 15 steps. Rather, what you can do is, you can club the cos square x with the numerator so that you will get secant square x dx minus secant x tan x dx. This is simpler. You will get the answer in one step. Integral of secant square x is tan x minus integral of secant x tan x is secant x, and plus c is the answer. Okay. So the rule that I told you, have it in your mind. I use it in every derivation. Sharia. So concentrate on that. And with respect to trigonometry, these are all simple problems. So you don't have a problem because it's direct application. But I'm telling you again, in trigonometry, you will have multiple answers possible. I'll tell you how to find that as when we solve trigonometry problems. Till here, is there any doubt? So we discussed only the basics today. Tomorrow we'll go into slightly next level. Okay. Is that clear? So we'll wind up with this. Okay. Okay. Yeah. So yeah. Anga clean ayilada. Okay. Yeah, Hariharan. Hariharan, this Raghav. 1 minute. So on the first day,